one of the whole points of your skeleton is to allow your movement, and so they become the anchor upon which your muscles get to squeeze. And there's just a couple of different ways we can attach muscles. We can attach them directly, epimysium to periosteum, or we can use little ropes or sheets to kind of make that attachment indirect. The ropes would be tendons, the sheets would be aponeuroses, like you see here with your rectus abdominis, hooking up your xiphoid process down to the pubis of your pelvis, right? And it's a flat sheet instead of a rope, but it's the same basic thing, indirect attachments. Now for every muscle, these are linear structures, right? They attach from point A to point B, and the only thing muscles can do is squeeze. And so because these guys are ropes, basically, with a squeezy ability, where we attach them matters. Because they're only going to be able to squeeze, and if they're attached in the wrong spot, then the motion becomes wrong. Well, the attachment point here is always going to be causing some version of motion. And you notice as I'm moving my body, what happens is, in relation to a particular joint, one side of that joint stays relatively still, and the other side of that joint is moving quite a bit. In these muscle attachments, the side of the muscle attachment that's not moving, that's called the origin. In general, it's closer to the midline of your body, but not always, right? And next we've got the insertion, which is what's giving us the moving. So we're going to squeeze against the origin so we can pull the insertion closer to us. And that's it. That's all the muscles can do. They can squeeze and they cannot squeeze, and we use gravity or other things, opposing muscles, to pull this guy back. As we get into the muscles of the head, the frontal lobe is covered by the frontal bone in the frontal region of your body, and right up front we've got the frontalis muscle. So if you're screwing up forehead stuff, guys, I pity you, because it's all frontal stuff, right? Anything here, just some version of frontal. And frontalis is this motion. Lift your eyebrows, that's all. That frontalis can be considered as its own muscle. It can also be considered as part of a larger muscle called the epicranius, which also includes back here the occipitalis over your occipital bone, right? But you can call it the frontal belly, the occipital belly of the epicranius, or you can call it frontalis or occipitalis. I'm not sure which way your lab instructor decided to go with this. They're synonyms. And so the other bone we've got, if you can wiggle your ears a little bit, I can with incredible focus. I've been practicing. All right, that's your temporalis muscle, right? And some people can really get it going. Other people got nothing. Yeah, that's a genetic thing. All right, and then as we move forward, we've got your crushing muscles for your jaw. That's your masseter muscle back here. Hooks up to your zygomatic arch and then inserts into the back corner here of your mandible. Questions here? All right. The other neck muscle we've got is the muscle that's going to allow you to do the oblique action of your head. When you squeeze, you go top right to lower left or vice versa, right? And this is your sternocleidomastoid muscle. The name of the muscle tells you what it's attached to. It's attached to the sternum. It's attached to the clavicle, clado. And it's attached to the mastoid process of your temporal bone. That's where we get the name. But in the end, that muscle is this. And when you pull it, it pulls you down into the side. Questions here? Sternocleidomastoid. It's a favorite. Because to spell it right, you need to have studied, and it's fun to say, and it's insanely easily recognizable. Right? So most people are asking this one. So, strategy. I will likely be asking that one, my kids. Major strategy. All right, then we've got these powerful muscles of your humerus, right, to give you the push and the punching and the pulling that you need. And the push is the pectoralis major here. The reason why you have that flat body of the sternum is so we can attach this big muscle to at least some version of surface area and get us the strength that we need. The other thing we've got is your deltoid, your chicken dance muscle. This is hooked up here, and then it comes down to about the middle of your humerus and pulls that, and so this brings us up. Your deltoid will only allow you to get you up this far. If you do any time at the gym with shoulder exercise, you understand that deltoid maneuver is up to this. It's not up to that, it's here. Why? Anything further, you're not doing deltoid. Anything north of that, you're working traps now, your trapezius in the back. And so we're getting you the chicken dance only to here with your deltoid. We've got a few different areas of it, but in the end, it's your shoulder muscle. So called because the Greek letter delta is a triangle, and this muscle looks like a triangle. Questions there? All right. Your trapezius is another geometrically named muscle, and this sucker looks like a trapezoid. It goes all the way up and attaches to your occipital bone of your skull. It comes down, attaches to your cervical vertebrae, and then continues to attach to every single thoracic vertebrae you have. And so this trapezius muscle really is most famous for giving football players no necks. And you're actually, if you've ever had a football practice, you grab on your face mask and you roll over the top of your helmet like this. You're strengthening those muscles so your neck doesn't get ripped off while you're playing the game. That's literally why people do that. It's not so they can look all big and tough. There's no aesthetic reason for this. It's functional only when you do that big traps thing. Call it a trapezius because it looks like a trapezoid from your geometry class. Yes? Questions here? All right. Then you get your pulling muscle, your rowing muscle, your butterfly swimming muscle. You ever seen Michael Phelps? You ever seen Michael Phelps do this? And the guy looks like a freaking squirrel coming down in his tiny little waist and these massive wings coming off his back. And why? Because he's constantly pulling himself through the water with this action. Or if you're rowing, you're doing this. So whereas the pectoralis is pushing, your latissimus dorsi here is the pulling muscle. And is responsible for more of the triangular look of somebody who's really kind of muscular, right? That's that. It's pulling. Questions? All right. Then we've got your rectus abdominis. Rectus just means straight, right? And abdominis is your abdominals. Hooked up by an aponeurosis. This is going to take your xiphoid process and pull it closer to your pubis, right? So that's the general sit-up. But we've also got this motion. Oh, but wait, we've also got that motion. And oh my God, we've got that motion too. And so we've got the full circumduction going on around these very flexible lumbar vertebrae. But we understand that muscles can only squeeze in one direction. So how are we getting all of that play going on in this area? It's because your obliques here have 3 separate layers. We're asking you about the external oblique specifically. However, we've also got 2 other layers inside. And notice the grain of these particular stakes. One's going diagonal this way. What that does is when it pulls you that way. And only that way, the diagonal. Incidentally, that's why it's called oblique. Oblique means at an angle. Yeah? All right. Then we've got another one going the exact opposite oblique angle, just inside. Well, when we don't want to go that way, but we want to go this way instead, we leave the outside muscle alone, we go to the middle muscle, because that's pulling the right way. And if I don't want to do any diagonal motion, I just want to spin, I go to the most inside, look at that grain, and now I do this, right? And so the way we get all this variation in motion is to stack muscles on top of each other, each orienting themselves a different direction and firing them off when necessary. Make sense? All right. Now down away from the torso and into your limbs. Your biceps brachii has 2 attachment points at the origin. That's why the biceps brachii, because what's this area of your body? It's the brachial region. You're not allowed to just call it biceps. Because while you have a biceps brachii here, you also have a biceps femoris back here in your hamstrings, and they're both biceps. And so you will not get full credit if you only say biceps, especially with the muscles. If there's many words you need to write out to give you the right answer, write them all down because they all are there for a reason. Right? We scientists are just as lazy as everybody else. We've just got a little bit more to keep track of, so we've got to add the complexity. But it's not complexity for no reason. So your biceps brachii gives you the flexion of your arm. On top of that, we've got the triceps brachii, which gives us the extension of the arm, the opposing muscle groups, right? Moving forward, moving down, you've got the brachioradialis, which goes from your brachial region down the radius. Brachioradialis, so it's the thumb side bone. If you've got anybody you know who likes to sit there and squeeze tennis balls or do the grip strength thing, this is where we're actually focusing on with that grip strength training, is the brachioradialis right there. These others, they have names, but in all cases, we're just going to call these guys the flexors of the forearm. on the inside. Opposite side, the extensors of the forearm. Done with the arms and the upper. Questions there? All right, guys. So then we've got the legs. Gluteus maximus is your butt, and it's the largest muscle you got. That's why it's maximus, from the gluteal region. As we get to the hamstrings down here, we can't call them hamstrings. What we've got is a biceps femoris, which is going to go lateral, and a semitendinosus, semimembranosus system that will go medial. And that's the only way to tell these different muscles apart, as far as I can tell, where they insert at the end. So they both are sitting up here on your ischium, and they come down, again, biceps femoris attaches at the knee lateral, semitendinosus attaches at the knee medial. This is one of the most common screw-ups on a practical, is those two muscles. And that's how you keep track of them. As we move to the front, we've got your crisscross applesauce muscle. It's called the sartorius, so called because a tailor is a sartor, and tailors crisscross applesauce in front of you and take the leg measurements for your pants, yes? And so it's called the tailor's muscle, and this is the move you're doing with it. It's the one that comes from your ilium all the way down across the medial side of your knee. And that's why we can do the crossed leg thing with it. So that's a very obvious one. And that is this muscle here. I should have been pulling these models out the whole time. All right. From there then, you've got your quads, your quadriceps. We're not going to call them quadriceps. You've got a rectus femoris that runs right down the middle and attaches directly to your patella, your kneecap. And then on either side, you've got the vastuses. And the vastus brothers are vastus lateralis and vastus medialis. And that's it. Together, quadriceps, because four heads all through them. Questions there? Don't call them the quadriceps. You won't get credit. Maybe in the gym, but not in our lab. Moving down now. We've got the gastrocnemius, is your calf muscle. That hooks up to your calcaneal tendon, to your heel, and when you squeeze that, you point your toes forward. That's it. For my class, you also need to know the soleus muscle underneath, a little bit deeper, doing the exact same motion. It's a stabilizer for that muscle. Up in front, you've got your shins, and your shin muscle, well, this muscle is right in front of the tibia. It is anterior to the tibia, which is where the name tibialis anterior comes from. Literally, it's telling you exactly where it is. It's not one you're allowed to screw up. So I usually put this one on my practical FIM simply because I'm trying to feel nice just then. Because, come on, man, do a little bit of effort. All right, with that, we're done with all these muscles. The rest of this just is a little bit more detail if we had time, which we do not, so I'm going to continue moving on.